Let's talk about composite figures. A composite figure is made up of simple shapes. It could be a combination of triangles, rectangles, trapezoids, circles, parallelograms, any type of polygon you can think of. To find the area of the composite figure, you need to find the areas of shapes that you know and then use the area addition postulate. Let's look at some examples. Let's take a look. First thing you should do is make a list of the shapes that you see. Here, hopefully you see a semicircle, and the rest of it, hopefully you see a trapezoid. Now, are those the only ones that you could use? Absolutely not. Some people may see a triangle and a rectangle and do it that way. I'm going to use a semicircle and the trapezoid. So the first thing we need to do is to find the area of the semicircle. Make sure you are labeling your work so that way I can tell what goes with what. So for the area of a semicircle, we know that's going to be half pi r squared. If the diameter was 20, we know the radius is 10. So 1/2 times pi times 10 squared, which gives us 50 pi millimeters squared. So we can fill that in over here. Don't forget your pi. This is the exact answer. When you type pi in the calculator and multiply, that gives you an approximation. My advice, keep everything exact until the very end. Now let's look at the trapezoid. To find the area of a trapezoid, we have 1/2 base 1 plus base 2 times the height. So when we substitute in what we know, base 1 is 32, base 2 is 20, and the height is 14. We can simplify, do 1/2 times 52 times 14, which would give us 364 millimeters squared. So now we have the area of the shapes that we divided this composite figure into. So in order to find the composite figure, we don't have any missing areas, so we just need to use the semicircle plus the trapezoid. And when we substitute in 50 pi plus 364, we're going to leave the exact answer. And remember, we cannot combine those numbers because they do not have the quote same last name. So you can leave it as 50 pi plus 364 millimeters squared. Now I know it said round to the nearest tenth, so from here you could type it in the calculator and get your decimal approximation. But I'm going to leave it like this so you can see what the exact answer looks like. Let's look at another example. This one has a lot of lines going on, but if we were to shade in what we see, right here I see a parallelogram. And then right here, that leaves me with a triangle. So I know I have a parallelogram and a triangle. Again, you may see different shapes, but it also helps to look at the information that you're given. So if we were to do our parallelogram, we know that to find the area of a parallelogram, we do base times height. Well, looking here, here's our height because we found the right angle. So the height is 5 feet and the base is 8 feet. So that's simply 8 times 5, which is 40 feet squared. When we look at the triangle, the area of a triangle is 1/2 base times height. Well, notice here's the right angle, so we know that our height is 5 and our base is 10. So we can just substitute in 1/2 times 10 times 5, which does give us an area of 25 feet squared. Now, in order to find the composite, again, we notice there are no missing areas, so we know we're going to have to add these two shapes together. So a parallelogram plus a triangle, which would be 40 plus 25, which gives us an area of 65 feet squared. Now let's look at this one. We want to find the area of the shaded region. Well, if we notice, you see a whole triangle, but we also see this semicircle here that's taken out of it. So we have a triangle and we have a semicircle. So let's find the areas of each one. For that triangle, we're still using the area as 1/2 base times height. We get that, here's the right angle, so we have our height, we have our base, so we can substitute in. When we simplify, we get the area as 234 feet squared. And if you've noticed throughout this video, I've been using symbols to represent the polygons, and that's fine. You can either write them out or you could abbreviate and draw a picture. Let's look at the semicircle. The semicircle, remember, is half the area of a whole circle. Notice this 9 here is the diameter. We want the radius, so 1/2 times pi. The radius would be 4.5, because 9 divided by 2 is 4.5. So we can substitute that in. And we can multiply 4.5 times 4.5 divided by 2, which gives us 10.125 pi feet squared. Again, leave this as the exact answer until the very end. So the area of the semicircle is 10.125 pi feet squared. Now to find the composite figure, remember before we didn't have any areas missing. Well, now we have the semicircle taken out of the triangle, so to find the area of the composite figure, we have to take that triangle and subtract out the semicircle. So when we plug in our information, substitute in our information, we have 234 minus 10.125 pi, and you could leave this as your area in feet squared. This is the exact. But if the question says round to the nearest tenth, we type it into the calculator and we get that the area is approximately 202.2 feet squared. When you're typing it in the calculator, for pi, make sure you use the pi button on your calculator. So make sure when you're doing composite figures, you pay attention to whether you need to add the figures or maybe subtract something out, or maybe a combination of both. This next question is a question you're going to do to bring to class to show that you understand this concept. A company receives an order for 65 pieces of fabric in the given shape. Each piece is to be dyed red. To dye 6 inches squared of fabric, 2 ounces of dye is needed. How much dye is needed for the entire order? So make sure you show your work, bring this to class, and be ready to talk about it.